I'm Sam.
And I'm Clara. And today we're looking at something really fundamental for coastal areas: erosion. Specifically, how to protect against it.
We're focusing on a project in France, Cayeux-sur-Mer, where they implemented a solution using materials delivered by ArcelorMittal.
Right, so this area, the Boschance coastline in the Bay of the Somme, it has a natural defense, this pebble beach.
And that beach protects a huge low-lying area, over 4,000 hectares, from the sea. But the problem was, this beach was eroding quite badly.
Putting that whole area at risk.
A significant risk, yeah. And to understand the fix, we need to talk about something called a groyne. What exactly is a groyne in this context?
Okay, so think of it like a wall, or maybe a short pier, built straight out from the shore, perpendicular to the coastline. Its main job is to slow down the water moving along the coast and, crucially, traps sediment sand, pebbles that would otherwise get washed away. It fights erosion.
Gotcha. So our mission for this deep dive is to explore how they used a whole network of these new groynes in Cayeux-sur-Mer to combat that erosion and reduce the flood risk.
So the project involved putting in 24 new groynes. These were added to a system that already had 80.
So quite an extension. And like we said, the erosion was severe, threatening that large area behind the beach.
And it wasn't just the groynes, was it? They did something else, too.
That's right. They also brought in a huge amount of pebbles, nearly 250,000 cubic meters, to replenish the beach along about 2.2 kilometers.
Wow, that's a lot of pebbles.
It really is. So you have the new groynes designed to hold the beach stable, plus this added material. The combination really aims to strengthen that defense and cut the flood risk.
Let's get into the groynes themselves. How were they actually built? What makes them strong enough?
Well, the core structure is made of steel sheet piles. You can picture these as strong, interlocking steel panels driven deep into the ground. They use different profiles, PU12, PU18, and PU22, depending on the forces they needed to withstand. And the steel itself was a high-strength grade, S355 GP.
And how long were these piles?
They varied quite a bit, from around 3.8 meters up to 10 meters long, so pretty substantial.
Definitely built to last. What about the top part? What you'd see sticking out?
Good question. They're capped with a reinforced concrete beam, for structural integrity. And then on top of that, there's an edge made of azobe hardwood.
Azobe?
Yeah, it's an incredibly dense, durable tropical hardwood.
Interesting. Now, I heard there wasn't just one standard design for these groynes.
That's correct. Most were what you'd call single-pile groynes, basically one wall of those sheet piles with the capping.
Okay.
But they also built double-pile groynes. These have two parallel walls of sheet piles connected by the capping structure. Naturally, these are even more robust.
Makes sense. Stronger design.
Yeah. And on some of the double groynes, particularly on the north face, which takes more of a beating from the waves, they added extra protection, a pre-face panel, about 16 centimeters thick, along with the usual embankment pebbles.
So tailored protection. What were the typical dimensions?
Most of the new ones are between 85 and 90 meters long, reaching out into the sea. They're about 90 centimeters wide and spaced roughly 90 meters apart along the coast.
And you mentioned some specials.
There were 3 wider double groynes, about 5.16 meters wide. One serves as a ramp for beach access.
Ah, practical.
Another provides access for emergency vehicles and pedestrians, which is vital. And the third one has that beefed-up northern face for extra erosion resistance in a potentially tougher spot.
Makes sense to have those variations. So how do you actually install these massive steel piles? You can't just hammer them in, surely.
No, not quite. They used a specialist piece of kit called an ICE 28RF vibro driver.
Vibro driver.
Yeah, it uses vibration to drive the piles into the ground. But this model is specifically designed to be resonance-free, which means it minimizes ground vibrations and, importantly, noise.
Ah, that's crucial in your communities.
Absolutely. They had noise restrictions, so they even did acoustic monitoring on land and water. And they used non-metallic parts on the driver where it grips the piles, again, just to cut down the noise. A key thing they designed for was abrasion.
From the waves and pebbles constantly hitting the steel.
Exactly. The design actually allowed for a potential loss of steel thickness, about 7 millimeters total over the 30-year design life, purely from that constant wear and tear. And impressively, they achieved the required durability without needing extra coatings on the steel piles.
Now, we've focused on these groynes for erosion, but these steel sheet piles, they're used for other water-related issues too, aren't they?
Absolutely. Steel sheet piles are incredibly versatile. You see them used a lot for flood protection walls along rivers or to build cofferdams for construction and water, things like that. Their strength and ability to form a continuous, fairly watertight barrier is key.
So wrapping this up, the main takeaway seems to be that these carefully designed groins, built with robust ArcelorMittal steel sheet piles, combined with that beach replenishment,
are now a crucial defense for the Cayeux-sur-Mer coastline, significantly reducing that long-standing erosion problem and the associated flood risk for the community.
It's a powerful example of engineering meeting an environmental challenge head-on.
It really is. It shows how we can use materials, science, and smart design to protect vulnerable areas from, well, the sheer power of the sea.